Nikita, question number 10.19 কোনটোৰ পৰা homework কৰিব দিছিলো বা কিবা যদি দিছিলো বা Okay, hello everyone. Again, we are starting with the reactions. We have done till 10.9, question number 11. From ethyl chloride to propanoic acid, we have done the conversion. Now we go to the next one, number 12. Now what we have to convert? We have to convert but1 in 2 and butyl iodide. Okay. You know what you have to convert? You have to convert but1 into an butyl iodide. That means iodobutene to convert into iodobutene. So but1 in means 4 carbon, and in one position we have the double bond. So let us draw it like this. And in this way, if you draw, you will not get confused about the number of carbons what you have to add here. So CH3, CH2, CH, CH2. It is but1 in. But1 in, but1 in. You can convert into. Okay, here what you are going to do, you have to add a reagent so that it gets converted to an butyl iodide. For this, simply do one thing, add HBr in presence of peroxide. When you add HBr in presence of peroxide, what will happen? CH3, CH2, 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 and you will get bromine. Now after this we have a very famous reaction, that is the alkyl exchange reaction. If you do this one, you will just have to do this exchange of reaction and you are going to get the answer, this one. So simply but1 into an butyl iodide, or you can say an iodobutane, and iodobutane. Okay. Coming to the next reaction. Now I think all of you have written it. Now next reaction is, if you see, if we have the next reaction, we have the next reaction as number 13, 10.19, number 13. 10.19, number 13. If you check, what are you going to get? 2 chloropropane to 1 propanol. The question is 2 chloropropane, 2 chloropropane to 1 propanol, 2 chloropropane to 2, 2 chloropropane to 1 propanol, to 1 propanol. So if you check this, how to convert it, you have to first know how to write the formula. The formula is important. You have to remember, for every reaction, the formula of the reactant is very important. Once you know the formula of the reactant, then only it is easy for you to convert to any product, whatever it is asked in the question. Now let's go and check how we can convert, this particular compound. What is the particular compound? The particular compound is 2 chloropropane to 1 propanol. So for that, let us draw the structure of the compound. 2 chloropropane, 1, 2, 3. That means 3 carbon. Then we are going to add 2 chlorine to the second carbon, and then we will finish the number of hydrogen linked to that propane. Okay, now here let us do one thing. Let us use alcoholic potassium hydroxide, and when we are going to use this one, this will give us dehydrohalogenation reaction, and you will see that halogen and hydrogen both are removed. Now let us add let us add uh, what shall we add? HBr. in presence of peroxide, in presence of peroxide, what effect are you going to see? You will find that it is following anti-Marconics of rule, and the bromine is added to that carbon which has more number of hydrogen, is added to that carbon which has more number of hydrogen. Now this bromine can be replaced by alcoholic group if I add aqueous solution of potassium hydroxide, and it will give us the product 1 propanol, 1 propanol. I hope everybody has understood what you are going to do. You should know what you are going to do. Okay, this was the entire reaction to convert this into this. Okay, let's go to the third reaction. Let us go to the third reaction. Let us see the next reaction. Again, 10.19 isopropyl alcohol to iodoform, isopropyl alcohol to iodoform, isopropyl alcohol to iodoform. So it is a straightforward reaction. It is a straightforward reaction. This reaction you are going to get later on also, iodoform. So let's find out how to write the reaction isopropyl alcohol to iodoform. So what are we going to do? Isopropyl alcohol, let us write first isopropyl alcohol formula, and then we are going to do it. Isopropyl alcohol, alcohol 2, isopropyl alcohol, isopropyl alcohol 2, iodoform, iodoform. Okay, isopropyl alcohol. So let us write in this way. This is isopropyl alcohol, and if I add iodine in presence of sodium hydroxide, in presence of sodium hydroxide. So what are we going to get here? We are going to get CHI3, CHI3. We are going to get CHI3. Since we need the major product, we are going to focus on the major product only. It is a direct reaction. It is a direct reaction. So we are going to write directly the major product. Okay, no need to write the other byproducts. Just simply write this much. Okay, next we are going to go for chlorobenzene. This is also 10.19. Chlorobenzene, chlorobenzene, chlorobenzene 2, 2, para-nitro, para-nitrophenol, para-nitrophenol, chlorobenzene to para-nitrophenol. Now in chlorobenzene to para-nitrophenol, let us first convert write the formula. Let us first write the formula and then start doing this reaction. So for draw the structure of benzene nicely. Okay, this is chlorobenzene. If I add concentrated nitric acid and concentrated sulfuric acid, H2SO4, then what I am going to see, that 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 sorry sorry I'm sorry, let me write it nicely so that it looks nice. Okay, that nitro enters this particular position. Okay, after this, simply if I add aqueous solution of sodium hydroxide or potassium hydroxide in presence of acidic solution, then it easily gets converted it to alcohol. In presence of acidic solution, it gets easily converted to alcohol. Gets easily converted to alcohol. So instead of writing Cl here, what are we going to write? We are going to write this. Instead of writing Cl, we are going to write this. Okay, instead of going to write Cl, we are going to write this. I think we have done 15 number. Let us go to the next. Let us do the next one. The next one is The next one, the next one, number 16, is 2 bromopropane to 1 bromopropane. That means 2 bromopropane to 1 bromopropane. 2 bromopropane to 1 bromopropane. So let us do 2 bromopropane. At carbon number 2, we have bromine. After writing this, let us fill up the number of hydrogen, necessary hydrogen. Okay. Now this 2 bromopropane. So let us do alcoholic KOH we are going to use. As soon as we use alcoholic KOH, what happens? What happens? It removes the halogen and the hydrogen, and you get and you get the product as and you get the product as this. Sorry, it should be propane, and what I have written, it should be propane. I have written butane. So sorry. Uh, this to bromo propane, to bromopropane. Okay, to bromopropane. Number 16 is to bromopropane. So one, two, three. Two position there is bromine, and now we replace by this one as hydrogen. Okay, now let us take alcoholic KOH. Alcoholic KOH. What are we going to get? CH3 double one CH CH3. Okay, now here if I add HBr in presence of peroxide, what am I going to get? CH3, CH2, CH2, Br. This becomes converted to 1 bromopropane. 1 bromopropane. Okay, 1 bromopropane. This is the way we can get converted to 1 bromopropane. Okay, next is number 17. Number 17. Chloroethane, CH3, CH2, Cl. This is chloroethane. Now chloroethane to butane. So here also it is a very simple reaction. You just need to add sodium in presence of dry ether. So it follows the Oates reaction, and you are going to get double number of carbon in the final product. So if there was 2 carbon atoms in the reactant and 4 carbon atoms in the product. So this is next chloroethane to butane. Number 17. Number 18. Let us look for number 18. What is given number 18? It is given what? Let us see the next question for number 18. So benzene to biphenyl. So benzene, if you check this benzene to biphenyl. So benzene to biphenyl. So 2 benzene molecule, then sodium. Okay, you have to first convert this into your wait, you have to convert this. You have to first convert benzene benzene to biphenyl. So benzene to biphenyl. So in order to convert from benzene to biphenyl, what you have to do? We have to first convert benzene. We have to first convert benzene. It will, then what are you going to do? See, first convert benzene. First convert benzene. First convert benzene in presence of sodium. Remember that. Okay. This is benzene to biphenyl. Benzene to biphenyl. This is also in presence of dry ether. This is also in presence of dry ether. So the entire reaction you can see that it can be converted into this engine can be converted into biphenyl. And next is number 19. Let us go to number 19. It's 19, so the X should be written. Okay, number 19, tertiary butyl bromide. Tertiary butyl bromide. The tertiary butyl bromide, how it looks like tertiary butyl bromide. Tertiary butyl bromide, you are going to convert it into isobutyl bromide. So convert it into isobutyl bromide. Let's see how it looks. Tertiary butyl bromide to isobutyl bromide. So here tertiary butyl, let us first form the tertiary condition, and then we are going to do the further things. Alcoholic potassium hydroxide, dehydrohalogenation, so you can get products of this type. Okay. Now you have to convert it into isobutyl. Isobutyl, then what reagent you should keep? Plus, or you can directly write HBr in presence of peroxide. The anti-Marconics of rules will be followed, and you can write the product as this. You are going to get isobutyl bromide. Isobutyl bromide. Okay. Then next we can go for the next reaction number aniline to phenyl isocyanide. Phenyl isocyanide. So aniline to phenyl isocyanide. NH2. This is aniline. Aniline to phenyl isocyanide. So let us do carbon-amine reaction. It is a direct reaction. Actually, it is a direct reaction which you are going to get in the next chapters, upcoming chapters. So simply you have to write the reagent right now. Later on, this reaction will be explained in the other chapters where you are going to get this reaction. So this becomes isonitrile. This becomes isonitrile. So you just need to remember the main product. You just need to remember the main product. So these were the sums in 10.19 of haloalkanes and haloarine chapter. Now let us go to the next question, 10.22. Let us do the next question, 10.22. Once we complete 10.22, then we will come to 10.21. So 22 are the statement given somewhere. You have to follow the statement and find out the product. Just you have to follow the statement, what the statement tries to explain, or what are the reagents added in the particular statement. You have to understand the reactant, the reagent, where what is going to react with the reactant, and you are going to get the product. So product is your answer, but you are going to find out after seeing the reactant and the reagent. So the first question is N-butyl chloride means CH3, CH2, 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 Cl. N-butyl chloride, this is N-butyl chloride. So if it is allowed to react, if it is allowed to react with alcoholic potassium hydroxide, what are the products you are going to get? Alcoholic potassium hydroxide always do elimination reaction. So what you are going to do, you are going to find out elimination reaction. When you do elimination reaction, it is obvious that Cl will be coming out from this carbon, Cl will be coming out from this carbon, and one hydrogen from this carbon, and you will get a double bond at this position. So let us now write directly the product what you are going to get here. is simply a double bond. So this is the double bond. Here is the formation of the product, and the name of the product becomes butane. So I have changed the color so that you understand where is the difference from the reactant to the product. Okay, now next question. We are going to do the next question, number two. Number two, that is 10.22. Number two, 10.22. Number two, 10.22. Number two. Let us do it. Okay, bromobenzene is treated with magnesium in presence of bromobenzene. Bromobenzene. This is bromobenzene is treated with magnesium in presence of dry ether. So this reaction, this type of reaction gives us hint to the Grignard's reagent. So simply you have to write the product, name of the product. Simply you have to write the product benzene, magnesium, benzene, magnesium, bromide, benzene, magnesium, bromide, benzene, magnesium, bromide, benzene, magnesium, bromide. Done? Okay. Okay, I hope you have understood this part. Let us go to the next part. Next question, 2.22. 2.22 number 3. 2.22 number 3. It is chlorobenzene is subjected to hydrolysis. Chlorobenzene is subjected to hydrolysis. Hydrolysis means is treated with water. Chlorobenzene subjected to hydrolysis. So hydrolysis means aqueous solution. Hydrolysis means aqueous solution. So let us see what is happening. Chlorobenzene subjected to hydrolysis. Subjected to hydrolysis. Sodium hydroxide. Chlorobenzene treated with okay. Next is after this what you can write, after you have to write acidic condition and all, whatever name of the reagents, but whichever reagent is extra you can write it in the reaction, whatever you remember, but the main reactant don't forget to write that. Number 4 is ethyl chloride. Ethyl chloride treated with aqueous KOH, simply have to do substitution reaction. To simply do substitution. Next is methyl magnesium, methyl bromide plus sodium in presence of dried. What will be the reaction? Which reaction? So simply write the product in terms of which reaction. And the last reaction is methyl chloride. It will do replacement of Cl. So these are the product. These are the we are going to write what happens when. These are the product of this question. 10.22. Now let us go. Now let us go. Let us do the next and the last sum. Let us do the last sum. That is 10.21. 10.21. It is very important to read the question before we do this, because this particular question gives a hint to a number of equation, and it is very important that you should read it and then follow the reactions. Primary alkyl halide, the formula is given C4H9, reacted with alcoholic potassium hydroxide gives B, compound B. Compound B is treated with HBr to give C, which is an isomer of A. When A is treated with sodium metal, it gives D C8H18, which is different from the compound formed when N-butyl bromide is treated with sodium, which is different. Write the structural formula for this. So there is number of conditions given. So let us start from the first condition. What is the first condition given? It is said that react if I allow this to react with alcoholic KOH, this is compound A, it gives the product CH2, CH2, CH double bond, CH2. This alcoholic is this B. Now this B, if I treat with HBr, it gives C. Okay. If I treat this with HBr, so what am I going to get? CH3, CH2, CH, CH3, and this becomes an isomer of this. Of course, it will become an isomer. So B is product this one and C is this one. Okay. Now, now, when you treat, when A is treated with sodium metal and this A is treated with sodium metal, it gives a compound D. It gives a compound D. Okay, so it gives a compound D. So how it can, okay. So this is one condition which can be possible. And if I treat this, I should get a different. Now A, B, C are confirmed. More or less it is confirmed. So this A, if I treat with CH3, CH2, 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 Br. If I treat with wood national sodium and follow Wood's reaction, I should get a different product. CH3, CH2, 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 CH3. So this product, the product should be different. It should not be of the same type as this one. So I think this, the main hydrocarbon which we have taken is wrong. We can't take this hydrocarbon. We have to take one isomer of this hydrocarbon. So if I take this as the isomer of the compound, if I take this one as the isomer of the compound, so in this case, I think we can go for the final product. So this one, if I treat with KOH, then I get a product CH3, C, CH3, double bond CH2. Okay. Now this one on treatment with, HBr. What am I going to get? CH3, 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 Br. Okay. Now this one, the product, this is A, this is B, and C. Now C, if I undergo Wood's reaction, what will be the condition? CH3, 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 Br plus sodium. So this product will be of this type: CH3, 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 CH3. 1, 2, 3, 4, 5, 6, 7, 8, and this of the formula C8H18, which is different from the result of N butyl bromide, from the result of N-butyl bromide. So it is different from the result of N-butyl bromide. So these are the reaction A to B. You're going to write this one. B to C, this reaction, and C to the this reaction. So these are the reaction which is correct for the above equation 10.21. For this kind of reaction, it is very important that you know what is been asked in the particular question. You have to read the question, the conditions. So first conditions, let us try, then if it doesn't occur, then we will go to the next condition. Remember, this kind of condition reactions are usually a hit and trial method. So if in the first go, if you don't find the answer, then we can go for the second box, second type. So there, here you have seen the difference. You have seen the difference. Once I have tried the reaction with the N but N butyl bromide, but in the next case I have done with the isomeric way. So this is also a isomer of A. This is also a isomer of A. So the entire questions we have read and done in the exercise haloalkanes and haloarenes. Okay, everyone. Thank you. Thank you for listening to the talk. Okay, please go through it.